Every smartphone, gaming console, AI model, data center, fighter jet, and modern car depends on one thing: computer chips. And every advanced computer chip depends on a machine so complex that only a single company on Earth can manufacture it. That machine is called an EUV lithography system. Without it, the most advanced semiconductors simply cannot be mass-produced. This has transformed a niche industrial technology into one of the most important strategic assets in human history. Today, the battle over these machines sits at the center of the growing technological rivalry between the United States and China. Governments are investing hundreds of billions of dollars. Export controls are expanding. Supply chains are being reshaped. And a tiny number of companies now hold enormous influence over the future of global technology. To understand the chip war, we first need to understand the machine that made it possible. Imagine trying to draw billions of microscopic electrical pathways onto a silicon wafer. That is essentially what lithography does. A lithography machine projects intricate circuit patterns onto silicon using extremely precise light. The smaller the pattern, the more transistors can fit onto a chip. More transistors usually mean more performance and efficiency. For decades, chip makers competed to make these patterns smaller and smaller. This race pushed engineering to extraordinary limits. Modern chip features are measured in nanometers. A nanometer is 1/1,000,000th of a meter. Human hair is roughly 80,000 to 100,000 nanometers wide. The latest chips contain structures thousands of times smaller. Creating these patterns requires some of the most advanced manufacturing equipment ever built. And as chip designs became more demanding, traditional lithography methods began reaching their limits. The industry needed something radically different. That breakthrough became known as extreme ultraviolet lithography, or EUV. Why the United States entered the fight? Although ASML builds the machines, many key technologies inside them come from American companies. The United States recognized that advanced semiconductors are essential for economic growth, military systems, artificial intelligence, and national security. As concerns grew about China's technological rise, Washington began tightening restrictions on advanced chip technologies. The goal was straightforward: slow China's access to the most advanced semiconductor manufacturing capabilities. This strategy focused heavily on lithography equipment. Without cutting-edge lithography systems, producing the latest generation of chips becomes far more difficult. The United States worked closely with allies to limit exports of certain advanced semiconductor technologies. These restrictions quickly became one of the most visible fronts in the broader US-China technology competition. But China was not standing still. It began accelerating efforts to build its own semiconductor ecosystem. And that effort would require overcoming enormous technological barriers. China's race for self-sufficiency. For China, semiconductors represent both an economic necessity and a strategic priority. The country imports enormous quantities of chips every year. Dependence on foreign technology creates vulnerabilities. As export controls expanded, Beijing increased investments across the semiconductor industry. Billions of dollars flowed into research, manufacturing, equipment development, and talent recruitment. Chinese companies began pursuing alternatives to foreign technology. The challenge, however, is immense. Lithography is not a single invention. It is the product of decades of specialized expertise spread across many countries and thousands of suppliers. Recreating that ecosystem is extraordinarily difficult. Even if one component is missing, the entire manufacturing process can be affected. Still, progress continues. Chinese firms are investing heavily in domestic capabilities and searching for new approaches to advanced chip production. The outcome remains uncertain, but the race is accelerating. The hidden global supply chain. Many people imagine chips being built inside a single factory. The reality is far more complicated. Modern semiconductor production depends on one of the most globalized supply chains ever created. ASML relies on components from multiple countries. Ultra-precise mirrors come from specialized suppliers. Advanced software comes from different firms. Laser systems come from highly specialized manufacturers. Materials, chemicals, and production tools arrive from around the world. No single country controls every step. Instead, the industry operates as a network of interconnected expertise. This complexity creates both strengths and vulnerabilities. A disruption in one region can affect production worldwide. Natural disasters, geopolitical tensions, trade restrictions, or manufacturing delays can ripple through the entire ecosystem. That is why governments increasingly view semiconductor supply chains as strategic infrastructure rather than ordinary commercial products. AI changes everything. The rise of artificial intelligence has dramatically increased the importance of advanced chips. Training large AI models requires enormous computing power. That computing power depends on cutting-edge semiconductors. As AI systems become more capable, demand for advanced chips continues to grow. Data centers are expanding. Cloud providers are investing heavily. Governments are prioritizing AI development. This surge in demand makes lithography machines even more valuable. The companies capable of manufacturing advanced chips suddenly occupy a central position in the global economy. Control over semiconductor technology increasingly influences competitiveness in AI, defense, scientific research, and industrial innovation. The chip war is no longer just about smartphones or laptops. It is about the future of technological leadership itself. And that raises a critical question. Can any nation truly dominate such a globally interconnected industry? Who really controls the monopoly? At first glance, the answer seems simple. ASML controls advanced lithography. But the reality is more complicated. The company depends on suppliers across multiple countries. Its technology incorporates decades of international collaboration. Governments influence exports. Allied nations shape regulations. Manufacturers depend on equipment providers, and chip designers depend on manufacturers. The semiconductor industry functions less like a kingdom and more like a web. Yet ASML remains the most critical node in that web. Its EUV machines represent a bottleneck that few can bypass. That is why the company sits at the center of one of the most important technological rivalries of the 21st century. The future may bring new competitors, new technologies, or entirely new manufacturing methods. But for now, the world's most advanced chips still pass through a remarkably small gateway. We have reached the end of our expedition through the global chip war. Thank you for exploring with me. Stay curious and watch where you step.